Hello, welcome to another episode of Physics is Easy with Mr. Jesse. For this tutorial, I'm going to solve a problem that is related to thin lenses. This is one of the problems that I have given on WebAssign about thin lenses. It reads, the projection lens in a certain slide projector is a single thin lens. A slide 23.8 millimeters high is to be projected so that its image fills a screen 1.86 meters high. The slide to screen distance is 3.10 meters. So we have to realize here that the kind of image that we have is a real image, because a real image is an image that can be projected on a screen. And the lens that is capable of producing a real image would be a convex lens. So if this is our object here, that's our object there, it is placed in front of a convex lens, and behind the convex lens is a magnified image of the object. We say magnified because if we are going to look at the problem, it fills the screen that is 1.86 meters high. So the original height of the object is 23 millimeters. This is the original height, or the height of the object, and the image is 1.86 meters. So obviously it is magnified, and it is inverted because it is a real image. Alright, now the slide to screen distance is 3.10 meters. So if this is my object here, which is the slide, the distance from the slide to the screen where we could see the image is 3.10 meters. Let me just label that down. This is our object here, and this one here is our image. In determining the sign of our quantities, you have to take note of the direction of the incident rays. So in this case, the incident rays would be directed towards the right because we have our object on the left and the image being projected on the right. So then we will be able to have our distance of the object, or DO, which would be from the optical center to where the object is. This is our DO. And from the optical center to where our image is, that would be our DI. So here we should know that our DO is positive and our DI is also positive, because as the rule says that the sign of the quantity relies on the direction of the incident rays, and since we are measuring quantities from the optical center, then therefore DI is positive because we measure it from the optical center to where the image is. DI is positive. The first question says determine the focal length of the projection lens. So we have 1 over F is equal to 1 over DO plus 1 over DI. However, we don't know what our DO and DI is, but based on this illustration here, we know that DO plus DI is equal to 3.10 meters, or we could say DO plus DI is equal to 3,100 millimeters. And from this equation, we could translate this into DO is equal to 3,100 minus DI, or we could also say DI is equal to 3,100 millimeters minus DO. So we will now use this expression to substitute for DO in this original equation that we initially have. So we are going to now have 1 over F is equal to 1 over DO plus 1 over DI, which is 3,100 minus DO. Alright, we still don't have our DO, but we can actually solve for it because we are given in the equation that the height of the image is equal to 1.86 meters, which is just equal to 1,860 millimeters. And we also have the height of the object, which is 23.8 millimeters. Now we are going to use the magnification equation, which is HI over HO is equal to negative DI over DO. Now, since the image is inverted mainly because it's real, then we are going to substitute it with the following values. So we will have negative 1.1860 divided by 23.8 millimeters. There should be millimeters here. And that is equal to our DI, which is this expression here. That is 3100 minus DO. Do not forget the negative sign in the original equation. Do not forget this negative sign over here. Divided by DO. Manipulating this equation would allow us to solve for DO, and that would be equal to 39.17 millimeters. Now, this DO here is in fact the answer to the question in letter B, which is how far from the slide should the lens of the projector be placed. In fact, this is just DO. So now that we have DO, we could simply substitute that here in our equation for question A. So we will have 1 over F is equal to 1 over DO, which is 39.17, plus 1 over 3,100 minus DO, which is 39.17, and this would give us the focal length to be equal to 38.67 millimeters. And therefore we have solved for A and B. And that concludes this tutorial. Once again, always remember, physics is easy with Mr. Jesse.